Howdy folks, and howdy nicer analysts. I've gone ahead and investigated the reported timing noise between 18 and 30 Hertz. Previously, we investigated the reported 55 Hertz noise and found it consistently through MPUs 0 through 6 and that unfiltered data. I'll encourage you to check out that video if you haven't done so already. But since quite a lot of that was done looking at data gathered from observations of the Crab pulsar, I was concerned about looking at the 18 to 30 Hertz noise that was reported, since the Crab pulsar's spin frequency at roughly just below 29.6 Hertz would be present in that 18 to 30 Hertz range. But as you can see, we clearly have some noise in this MPU0 unfiltered data. But before investigating that further, let me remind everyone that I am an independent researcher. I am unaffiliated with NASA, the Goddard Space Flight Center, HESARC, or the NICER team or the NICER mission. I'm also not currently affiliated with any academic institution. That said, let's investigate this noise that we're finding in this MPU0 unfiltered data for the OBS ID 201.008.01.05 for observations of Cassiopeia A. Here between 18 and 30 Hertz, you can see three strong signals. Please ignore the full width half max, as the code that is running on the back end is trying to fit a full width half max to all three of these Gaussians across the entire domain, which obviously is not going to work. We see our first signal here at roughly 19.999 Hertz, the second one at 24.998 Hertz, and the last one at 29.998 Hertz. Now, this is done using the ZN squared statistic, which is much like taking a Fourier transform, except these Z1 squared values on our y-axis are statistically equivalent to a chi-square with 2 degrees of freedom. So naturally, we have well over 5 sigma detections here. If it is greater than 5 sigma, generally we consider it to be a detection. Taking a look at the MPU1 unfiltered data for this dataset, we see similar noise features, as well as in MPUs 2, 3, 4, 5, and 6. After taking a look at a number of datasets from CAS A, I've seen these three signals to be consistent through all of those datasets. So let's now zoom in on these results and get a better look at them. So here you can see a zoom in on the Gaussians of these three results. This is from OBS ID 501.301.0112 from an observation of the Crab pulsar. And in this first exposure interval from this observation in the MPU0 unfiltered data, you can see three very strong results. One at 19.9987 Hertz, another at 24.9985 Hertz, and then at 29.9983 Hertz. In the second exposure interval of this dataset, we see a signal at 19.999 Hertz, 24.9986 Hertz, and 29.9982 Hertz. We see similar signals in MPU1 with the first exposure interval, as well as in the second exposure interval. These also consistently show up in the MPU2 unfiltered data, as well as the second exposure interval in the MPU2 unfiltered data. Now, just taking a look at the first interval of the MPU3 unfiltered data, here you can see from looking at the entirety of this domain, we see the Crab pulsar's spin frequency in here, and we see that consistently through the unfiltered data coming from MPUs 4, 5, and 6. But when we take a look at the MPU7 cleaned event data that has been barycenter corrected, going all the way up to the edge of that Crab pulsar spin frequency, we see nothing but noise with these very small values in both exposure intervals. We know that the spin frequency of the Crab pulsar does show up in the MPU7 cleaned event data for this OBS ID 501.301.0112, as you can see right here. But then using that same data set, which again is the MPU7 cleaned event data, going from the Crab pulsar spin frequency to 30 Hertz, we see nothing but noise. Taking a look at another MPU7 cleaned event dataset that has also been barycenter corrected for OBS ID 106.0020.138, which is an observation of pulsar J0030 between the 18 and 30 Hertz range, as well as the range in which we were finding the 55 Hertz noise before. We are seeing nothing but noise. I've gone ahead and tested about 12 different datasets from 4 different sources, that being the Crab Pulsar, Cassiopeia A, Aquila X1, as well as Pulsar J0030, and I'm consistently seeing nothing but noise around these frequencies in the MPU7 cleaned event data. That all said, this is where I am finding noise frequencies in the unfiltered MPU data. Let me remind you that this is across MPUs 0 through 6 and the unfiltered data, and I have not found any evidence of any of these signals in MPU7 cleaned event data that has also been barycenter corrected. So as far as my work is concerned, since I'm mostly working with MPU7 cleaned event data that's also been barycenter corrected, I'm not super concerned about this noise. However, those of you that are working with unfiltered data should be well aware of those noise frequencies, as well as those of you who find any signals in MPU7 cleaned event data. I would go ahead and do a detailed analysis at these frequencies to ensure the result you are seeing is actually not a noise frequency. So that said, if you have any questions, comments, or concerns, don't hesitate to reach out and ask. I want to thank you all very much for watching, and let me just say quickly that I'd like to start making more videos about neutron stars as well as my research work, so look forward to that coming out for those of you that are interested in those topics. Again, thank you very much for watching, and I'll hope to see you again next time.